Welcome back, friends. Okay, today we are going to continue our conversation on the systems of equations, and we're going to actually look at a graph now. Now that we know that, okay, a solution makes both statements true. Graphically, that's going to look a little differently than it does when we are writing out equations. Because here, if you notice, it says graph a system. It doesn't give you a solution. It says graph a system and find the solution. So when the solution's provided for you, you can just check it. But when it's not provided, you're going to have to do some work. And what we're looking at today is you will need to graph both equations and then find the solution. Okay, graph both equations. Y equals x minus 2 and y equals 4x minus 5. That we can do because we know how to graph in y-intercept form, right? Y equals, we would start at, there's our b. Remember, y equals mx plus b. So in this equation, we would start at -2. And then our slope in front of our x here, or that would be that imaginary 1. Okay, so up 1, and as a fraction would be up 1 over 1. We could go up 1 over 1. And then we could draw that line. All right, so there's one line. But it says that we need to graph both equations. So we're going to look at the second equation. Y equals 4x minus 5. The b, right there, -5. So I'm going to go to -5. Oh, -5 is right here. And then I'm going to use my slope. Remember, slope is in front, so that would be 4, or 4 over 1. I'll go up 4. 1, 2, 3, 4, and over 1. Well, that's really nice that it landed right there, but we are going to, 1, 2, 3, 4. If I'm drawing by hand, I'm going to give myself a couple points. And then I'm going to go ahead and create that line real quick. Well, now I have two lines on the same graph, and that's what a system is. We have at least two lines, at least two, on the same graph. But it wants to know the solution. And the solution is all about what makes both of them true. So another way of thinking about that is, well, to make both of them true, it has to be on both of the lines. Would that not just be where they intersect? So where do they intersect? Well, they intersect right here, right? And that point there. Well, they intersect on that point where I just drew the green dot. What is the name of that? What is that solution called? Is what they're wanting to know. What is that solution called? And the solution here, this looks like that would be 1, -1. So here my solution is 1, -1. Okay, so let's just take a quick look at another system, and we're going to use graphing again because it says graphing a system. It says graph both equations. You're like, well, there's already one there. Yeah, I already have the green one on there. So the green one says, if we look down here at the actual equation, it tells us we have y equals x plus 4. See that y equals x plus 4? That's the green line represents, and that works well because it has the green box. So it started at 4, and then it had a slope of 1, right? Up 1 over 1. I can see that. Perfect. But then I see this. I have x equals -4. That's different, right? What's the difference in the two equations? Yeah, hopefully you said, well, that's in slope-intercept. That's y equals mx plus b. This is just x equals. Do you remember VUX? Remember, that's a vertical, undefined. Ooh, undefined, what does that mean? Undefined, vertical, undefined. Remember, too much fun? And it looks like x equals, and it does. It says x equals -4. So I'm going to go ahead and get this on my graph. X equals -4. What equals -4? Well, anywhere, right? So I'm trying to graph it. It doesn't matter where my 2 points are. Nope. I just need to make sure it's a vertical line that is on -4, where x is always -4. So let me get that line for us. Okay, so now that our line is on, so we have two lines. That's perfect. Remember, graphing a system, those are actually two equations, two linear equations drawn as two lines on the same graph. I need to figure out their solution. The solution is all about what makes both of them true. So what point lies on both? So I look and I'm like, oh, well, it's right here, right? Right where they intersect. And I need to name it. That's what a solution is. I need to name that solution. Well, that solution is -4, 0. So to graph, you graph both lines. And then you look to see, okay, where do they cross? Where is that intersection? What coordinate, what location, what point, what ordered pair makes both equations true?